Problem solving with logs. Solving equations by taking logs. We need to solve 3 to the power of x is equal to 20. So one method is to rewrite this in log form. So we start with the power, which is what we're looking for. So power equals log. The base here is 3, the base here is 3, it's always the same, and the value left is 20, so it's log 20 to the base 3. So we can put that into a calculator and get the decimal value for this. Method 2, take logs on each side. So we write the word log once on each side, and I'm going to use base 10. It has to be the same base. It can be any base, but it has to be the same on both sides. And then if we bring the power to the front here, so x log 3 equals log 20, and then x is multiplied with log 3, so we need to divide by log 3 on each side, and that's what x is equal to. And this solution and this solution, the values of x are exactly the same. You should verify that on your calculator. Now when we took logs at this stage, I chose base 10, and you can choose any base that you like. Now it was 3 to the power of x, so the base there was 3, so 3 would be a wise choice as well when taking logs. So here's another attempt using the same method. So all I've done here is I'm taking logs on each side to the base 3, and then the power can move to the front. And when the power moves to the front, then we know log 3 base 3 is 1. 1 times x is x. So x is equal to log 20 to the base 3. The same solution as up here. Now when you take logs on both sides of an equation, you have to be careful. Let's say if a is equal to b. If you take logs on each side, then you can do this. Log a is equal to log b. You write log once on each side. Okay, let's say if a was equal to b plus c. Now when you take logs on each side, this would be wrong. You can't do this. What you should do is put everything in brackets here because we have multiple terms, and write the word log once on each side, not in front of every term. When you have an equation where you have a single log on each side, you can cross these out and then go back to a is equal to b plus c. I could have crossed these out and go back to a equals b. Example 2. So we're looking for x, and it's in the power. So I can write this in log form. So power equals log base 5 of 61. And then I need to add 1 to this and then divide by 4. That's the exact value of x. The alternative is to take logs on each side. So I need to write log once on each side. And this 4x minus 1 is a power. It can move to the front. And the base that I've chosen for my logs could be base 10. Base 5 would be a good one to use as well, because I already have a base 5. So if I stick with base 5, because it will help simplify, because I know the value of this is 1, so now I have 4x minus 1 times 1. Add 1, divide by 4, same as before. This looks like it's a disguised quadratic, and to test this, if I take the middle term, just the x term, not any coefficient, if I square 5 to the power of x, I need to test to see if I get the x term here. So I have 5 to the power of x. I'm going to square that term. So if I multiply the powers, I get 5 to the power of 2x, which is exactly what I have here. So this is in the form of a disguised quadratic. So if I let v be equal to 5 to the power of x, then I have this quadratic equation solving, and then I need to undo v and go back to 5 to the power of x, and using the log form for each, I have some solutions. Now this is a modified version of the previous problem. I've changed this part to 2x plus 1. So now if I take my middle term, 5 to the power of x, and if I square this term, I'll get 5 to the power of 2x, which is not the same as this. So at the moment this is not in the form of a disguised quadratic. However, I'm adding indices here, so this term can be written as 5 to the power of 2x times 5 to the power of 1, like this. And then if I just copy the rest of the terms, and now this squared will give me this. We're not looking at the coefficients, ignore those, just look at the x term. If we square 5 to the power of x, you get 5 to the power of 2x. So this equation can be written as a disguised quadratic. So v is equal to 5 to the power of x, and if v squared is 5 to the power of 2x, then I've got 5v squared minus 12v plus 20 equals 0. And the key learning point in this was, what do you do with a term like this? You have to split it and then continue.